Hello everyone! Welcome to the channel. My name is Eli. In this video, pag-uusapan natin yung concepts ng summation of forces and summation of moments. This is a very important topic na kailangan yung ma-master dahil magagamit siya sa lahat ng topics na pagdadaanan natin sa statics of rigid bodies. So let's begin. Sa statics of rigid bodies, madalas tayong gumagamit ng tatlong equation. That is the summation of forces along the x-axis, the summation of forces along the y-axis, and the summation of moments. Alam natin that a body is in static equilibrium kapag ka-equal to 0 lahat ng yan. Kapag ka-equal to 0 yung pinagsama-samang forces at pinagsama-samang moments sa isang rigid body, alam natin na hindi na siya gagalaw. Hence, we can say that that body is in static equilibrium. So let's try to write the summation of forces equation for this rigid body, body ABC. Okay? Pagka sinabi nating summation of forces along x, ibig sabihin lang nun, i-add natin lahat ng forces na nag-act along the x-axis. So, di ba? Ganyan. Ito yung x-axis natin. All of the forces that act along the horizontal plane. So may nakikita tayo dito, meron tayong 2 newtons at 5 newtons. When we write summation equations, kailangan natin mag-set ng conventions. Kung ano nga ba yung positive at negative doon sa equation na yon. So ang isa-set natin convention dito ay positive forces go to the right. So ganun yung ibig sabihin ng symbol na yan. So ilagay na natin dito yung 2 newtons. Papunta sa kanan yung 2 newtons. So positive siya. Add rin natin yung 5 newtons na papunta sa kanan. Ngayon guys, meron tayo ditong force na nag-act along point B equal to 7 newtons. At makikita natin no, may angle siya dito. Pero, meron kasi yung component, okay, na nag-act along the x-axis. So, kailangan natin masama yon sa equation na to kasi nga, summation of forces to along x. Kailangan natin makonsider lahat ng forces na nag-act along the x-axis. And so for that, i-isolate natin to para lang mas makita natin. Okay? Meron kang 7 newtons dito, si FB. Okay? Meron niyang component na nag-act along the x-axis. Meron din niyang component na nag-act along the y-axis. Okay? Alam natin na this is 35 degrees. At alam natin na 7 newtons yung magnitude or yung length ng ating hypotenuse. So, using our trigonometry, okay, makukuha natin yung components ng FB that act along x. So, yun yung FBx. And that is equal to 7 cosine 35. Dahil nandito na tayo, kunin na rin natin yung component ng FB na nag-act along the y-axis. And that is equal to 7 sine 35. Oops, ibahin ko yung kulay. 7 sine 35. Okay. Ngayon na nakuha na natin sila, pwede na natin i-plug in yung x component dito sa equation natin. Plus, tapos dahil nakikita natin na papunta rin naman sa right, yung x component nung force acting at point B, positive din siya. At isusulat natin siya ng 7 cosine 35. Next natin gagawin guys, isasum naman natin lahat ng forces na nag-act along the y-axis. So, kailangan ulit natin mag-set ng convention. This time, sasabihin natin na forces that go up are going to be considered as positive. So, kapag kapataas siya, positive. Kung pababa yung force, isusulat natin siya as negative. Okay? Ganun lang ulit, summation of forces along y. May dalawang forces tayo na i-consider. Una, itong 3 newtons. At pangalawa, yung y component nung 7 newton force acting at point B. So, sulat na natin sila. Meron tayong pataas na 3 newtons, so positive siya. Plus, yung y component nung FB, or force acting at B, which is equal to 7 sine 35. Okay? And just like that, consider na natin lahat ng forces that act along the x and the y-axis of our rigid body ABC. So, ganun lang siya guys kapag meron tayong force at an angle kasi usually, meron talagang forces that do not act purely along the x and y axis. So, gagamit tayo ng onting trigonometry para ma-breakdown natin yung force into its x and y components para masama natin sila dun sa ating summation equations. Okay? Next naman natin i-discuss yung concept ng moments. At kapag tinuturo ko yung moments, I like to use the example of an electric fan. So, sabihin natin meron tayong electric fan. Okay, ito siya. Yung kanyang axis of rotation, tatawagin natin point A. Ngayon, sabihin natin ayaw mag-on ng electric fan natin. So, kailangan natin siyang paikutin at itutulak natin siya with our hands. So, para umikot yung electric fan, kailangan natin mag-apply ng force, okay, doon sa blade. Okay? And that force will always be at a certain distance from the axis of rotation. So, tatawagin natin yung D. So, moments, guys, tinatawag tong torque sa high school physics, pero dahil engineering na tayo, moment na yung tawag sa kanya, is basically the tendency of a force to cause rotation. Mapapaikot ba nung force na yan, yung ating body, from point A? Okay? Kaya ang equation natin for moment ay m is equal to force multiplied by the perpendicular distance, okay, itong d, of the force from the axis of rotation. Okay? So, makikita nyo mamaya kung ano ibig sabihin ng perpendicular distance na yan. Pero for now, let's try to solve. So, kunwari, ito yung electric fan natin. Okay? I'm gonna call this point A. Okay? Yan. Tapos meron tayong force dito. Sabihin nating 0.8 newtons. Tapos, this is being applied at a distance that is 0.5 meters from point A. So, sabihin natin gusto natin itong isulat as a summation equation. Kahit na isa lang siya, gawin na rin natin. Kapag nagsusulat tayo ng summation of moment equation, guys, parang yung sa force lang, kailangan nating mag-set ng convention. So, in this case, isa-set kong convention ay clockwise is positive. And then, summation of moments at point A. Well, paano ba natin malalaman kung positive or negative yung moment? Nakadepende siya sa kung saan natin ina-apply yung force. And this is a skill na nakukuha through practice. Tinuturo ng mga libro madalas yung right hand rule. Pero personally, gusto ko lang imaginein kung paano nga ba iikot yung isang rigid body given a force that is being applied. So, kunwari, ito yung electric fan natin, di ba? Pag nag-apply tayo ng force dito, paano iikot yung electric fan? Iikot siya clockwise. Okay? Hindi naman siya pwedeng umikot ng counterclockwise kasi kinokontra niya yung force na ina-apply natin. The rotation simply follows depending on the direction and application of the force. So, dahil dito tayo tumutulak, iikot yan clockwise. Okay? Similarly, kung mula dito tayo sa other side nagtulak, kunwari dito, paano iikot yung electric fan? Iikot siya counterclockwise. Okay? Okay, so balik tayo dito. Sinet natin convention na clockwise ay positive. So, dahil magkakos yung 0.8 Newton force na to ng clockwise rotation ng electric fan natin, isusulat natin siya as positive. Okay? At ang equation natin ay force multiplied by perpendicular distance. So, susulat lang natin yun dito. The moment at A is equal to 0.8 newtons multiplied by 0.5 meters. Hindi nyo kailangan isulat yung units, guys, pero maganda na natatandaan nyo kung anong units yung ginagamit kasi minsan, kilonewton yan, millimeter ito, tapos kailangan natin i-convert yung final answer into newton meters. Pero in this case, hindi naman kasi newton at meter na sila. Okay? So, kapag sinolve natin yan, 0.8 times 0.5, it's equal to 0.4 Newton meter. Okay, so balik tayo dun sa concept ng perpendicular distance. Bakit perpendicular distance? Kasi not in all instances, makikita natin agad yung perpendicular distance ng force mula dun sa axis of rotation. Okay? Yan yung tinatawag natin na moment arm. Okay? Yung perpendicular distance na yan. Yung 0.5 meters. So, let's see a sample problem na hindi masyadong obvious kung ano yung moment arm natin. So, balik tayo dun sa ating electric fan, kunwari. Okay? Sabihin natin meron tayong okay, ito muna ulit. Sulat natin. This is 0.5 meters. Tapos, meron tayong force na ina-apply from this direction. Actually, wag. From this direction. Okay? From this direction. Tapos, sabihin natin 1.8 newtons siya. And it's being applied, okay, at an angle of 30 degrees from the horizontal. Okay. Ngayon guys, sabi natin, yung moment arm should be the perpendicular distance, no? So, kapag ka nag-zoom in tayo dito, dapat meron kang right angle dyan. Okay? Yun yung magsasabi sa atin kung gaano kahaba yung moment arm nung moment na kino-consider natin. In this case, ito yung force at alam natin na 0.5 meters ito, okay? It's very obvious na may angle ka dyan at hindi siya 90 degrees. So, paano natin masosolve yung moment arm for this problem, no? So, sabihin natin ganun ulit. Set nating convention ay counterclockwise. Summation of moments at A is equal to. Para makuha natin yung moment arm, kailangan nating i-extend yung line of action nung force na ina-apply. Okay? And then, magdodraw tayo ng line from the axis of rotation to the line of action of the force. That way, ma-maintain natin yung perpendicular distance. Okay? So, ngayon, yung haba na ito, ayan na yung moment arm na hinahanap natin. So, gagamit lang tayo ng onting geometry, guys, para ma-solve natin yan. Alam natin na may 30 degrees tayo dito. Alam natin na meron tayong perpendicular line dito. At dahil sa conditions na yon, simply malilipat dito yung 30 degrees na nandito sa taas. Okay? So, kung makikita nyo, meron tayong triangle dito, guys. Okay? Meron tayong hypotenuse na 0.5 meters. Meron tayong line dito that is at 30 degrees. Tapos, meron tayong right angle dito. So, from that, pwede na nating ma-solve yung moment arm natin using trigonometry. Let's call the moment arm R for radius. Okay? And we know that R is going to be equal to 0.5 cosine 30. Okay? So, meron na tayong moment arm. Alam na natin yung perpendicular distance. And just like before, pwede na nating ma-solve yung moment using the equation. Moment is equal to the force multiplied by the perpendicular distance. So, in this case, our force is 1.8 newtons. And our perpendicular distance is 0.5 cosine 30. So, kapag kinalculate natin yan, 1.8 times 0.5 cosine 30 is gonna be equal to 0.7794. 0.7794 Newton meters. Okay? So, ganun lang siya, guys. Ganun lang yung moment. Kailangan lang ng onting practice para ma-determine kung clockwise or counterclockwise ba yung rotation depending on the location of the application of the force. One last concept pala na gusto kong i-discuss with regards to solving for moments ay hindi lahat ng forces na na-apply sa isang rigid body actually causes a moment, no? Remember, the moment is the tendency of a force to cause rotation, and may certain forces that do not cause rotation. So, balik tayo dito. Ito yung ating axis of rotation. Kapag dito tayo nag-apply ng force, guys, directly on the axis of rotation, kahit anong tulak mo dyan, okay, hindi niyan mapapaikot yung electric fan natin. Similarly, pwede tayong mag-apply ng force dito sa taas. And if we draw the line of action of the force, makikita natin na it passes through point A, our axis of rotation. So, similarly, itong force na ito ay hindi makakapag-cause ng rotation ng ating rigid body. So since both of our forces pass through the axis of rotation, walang moment na na-experience yung ating rigid body. So if we write an equation for this, summation of moments at point A is simply equal to 0. So this is a good tip na kailangan yung tandaan na makikita rin nating ma-apply sa mga problems na i-discuss natin later on. Ayan guys, so ito na yung sample problem natin para matesting natin kung nagagamay na ba talaga natin yung concept ng forces and moments. So makikita natin dito, the following rigid body is in static equilibrium. Ang kailangan natin ma-determine ay yung magnitudes ng forces AX, AY, and FB. So just like before, meron tayong diagonal force na nandito. Lalagay natin yung kanyang X and Y components. So, meron tayong component along Y at meron din tayong component along X. Huwag kayo malito guys, for the purpose of illustration, dito ko nilalagay yung X component niya. Pero in reality, dito talaga siya nag-a-act. Okay? Yung head niya ay naka-point dito sa point B. So, the X and Y components of any diagonal force will always act on the same point as the original force. Pero for illustration, dito natin siya ilalagay para madali nating ma-visualize. The length of this hypotenuse, okay, is the magnitude of FB. So kung kukunin natin yung X and Y components ng FB, sulat natin sila. So BX is simply the X component of FB, or the force acting at point B. And this is going to be equal to, mali yung kulay. BX is going to be equal to FB cosine 45. And similarly, yung Y component, BY, is gonna be equal to FB sine 45. Ayan. So ngayon nasulat na natin, alam natin na meron tayong tatlong unknowns sa problem na to. Sila si AX, si AY, and si FB. Okay? Sabi natin kanina, when a force is being applied directly on a point, hindi siya pwede mag-cause ng moment at that point. So in this case, si AX at si AY ay parehas na nakatutok dito sa point A. Dumadaan yung line of action nila sa point A. So pwede tayong mag-sum ng moments at point A. Ang magiging unknown lang natin sa equation na yon ay yung magnitude ng FB. So if confusing pa yon para sa inyo, okay lang. Sundan nyo lang ako as we write this equation. So sabi natin kanina, kapag magsusulat tayo ng moment equation, kailangan natin mag-set ng convention kung ano nga ba yung positive at negative. So in this case, ang gagawin nating convention ay clockwise is positive, summation of moments at point A. Alam natin na the body is in static equilibrium, so this should be equal to 0. Ngayon, i-consider natin lahat ng forces along the body na pwedeng mag-cause ng moment at point A. Okay? Unahin na natin itong 837 newtons. Una nating isipin, positive ba or negative yung moment na makukos ng 837 newtons na force. So para dyan, i-visualize natin, ito si A, ito si B, ito si C, tapos andito yung 837 newtons na force. Kung ito yung electric fan natin from before, paano siya iikot kung dito tayo tumulak? Naturally, tutuloy yung body, yung rigid body, pababa, at iikot siya pa ganun. Diba? Iikot siya clockwise. So dahil magiging clockwise yung ikot na dulot ng 837 newtons na force, at sinet natin na positive ay clockwise, okay, likewise, positive siya. So remember, the equation for a moment is simply moment is equal to the force multiplied by the perpendicular distance. So alam na natin yung force, it's 837 newtons. Ang kailangan na lang natin yung perpendicular distance or yung moment arm. So balik tayo dito. Ito ba yung moment arm natin? Yung dalawang 0.6? Hindi. Kasi alam natin that the moment arm should be perpendicular. Okay, it should be the perpendicular distance. So if we draw the line of action of the 837 newtons force, pababa, And then we draw a line passing through point A. Ayan, perpendicular na siya. Ito na yung magiging moment arm natin, guys. Yung length na yan. We know that this is 17 degrees. And we know that the length of this is 1.2 meters. Therefore, using trigonometry, our moment arm would be 1.2 cosine 17. Okay. So, na-consider na natin yung 837 newtons. Consider naman natin yung iba pang forces na nag-a-act dito sa ating rigid body. Dito sa B, may dalawa tayong force na nag-a-act dyan. Yung x component at yung y component nung FB. Okay? So, sige. Unahin siguro natin yung y component. So, ito siya. Diba? Ito yun. Okay? Si BY. BY. So, kung ito yung electric fan natin, tinutulak nung BY pataas yung blade nung electric fan natin, naturally, tutuloy yan pag ganito at magkakos siya ng counterclockwise na rotation. So, dahil counterclockwise siya at clockwise is positive in our convention, sulat natin siya as negative. Ano yung magnitude ni BY? Sinulat na natin siya kanina. Ito siya. It's equal to FB sine 45. So, meron na tayong force. Ang kailangan na lang natin yung moment arm. Again, we need the perpendicular distance from the line of action. Perpendicular from point A. So, ito yun. Yung length na ito. And the length of this is 0.6 meters. So, using trigonometry, similar lang siya dun sa kanina. This is going to be 0.6 cosine 17. Okay? Last naman nating force na i-consider for this equation ay yung x component ng force that is acting on point B. At ito yon yung color green. Diba? Si BX. Okay? Ngayon, kailangan ulit natin mag-imagine kung ito yung electric fan natin from earlier before at tinutulak natin yung blade this way. Naturally, bababa yung blade natin pag ganito at magkakos yan ng clockwise rotation. So, dahil clockwise siya, susulat natin siya as positive. The force is equal to Bx, which is FB cosine 45. And then our moment arm, balik tayo dito. Ang moment arm naman natin dito, guys, again, perpendicular distance. So, ito yung force natin. Gano'n siya kalayo from point A. If we draw the line of action, okay, it's this distance. Ito. Tapos, meron tayong right angle dito. Alam natin na this is 17 degrees and that this is equal to 0.6 meters. So, our moment arm using trigonometry is 0.6 sine 17. Okay. Tapos again, hindi na natin kailangan i-consider si AX or si AY kasi hindi naman sila nagkakos ng moment at point A. If you solve this, you can solve this using algebra or pwede rin yung solver function ng inyong calculator. You would get that FB is equal to 3409.9066 newtons. Okay, so na-solve na natin si FB. And just like that, pwede na nating ma-solve si AX and si AY using our summation equations. So highlight natin ito. Isa na yan sa final answers natin. Mag-sum naman tayo ng forces along X. Again guys, magsiset tayo ng convention. Forces going to the right are positive. Summation of forces along X is equal to 0 kasi we are in static equilibrium. And this is equal to, okay, ano yung forces natin along X? Well, ito, si FB cosine 45. Pero dahil alam na natin na ito yung magnitude ng FB, pwede na natin siya i-plug in dito. So, ang magiging itsura niyan guys, 3409.9066 0.9066 cosine 45. At papunta siya sa kanan, di ba? Kaya positive siya. And then, our other force na kailangan i-consider ay si AX. Papunta si AX sa left. So, isusulat natin siya as minus AX. And all of this is equal to 0. You can use algebra or your calculators. At ang makukuha niyong sagot dyan ay AX is equal to 2411.1681 newtons. Okay. Nasolve na natin yung dalawa nating unknowns. Isa na lang, which is AY. And for AY, ganun lang din. Magsasum naman tayo ng forces along Y. So mag-set tayo ng convention. Kapag pataas, positive. Summation of forces along Y is equal to 0. Unahin natin tong 837 newtons. Dahil pababa siya, consider natin siya as negative. So this is equal to negative 837. Pataas yung BY. So susulat natin siya as positive. Insert ulit natin si FB dito. So ang magiging itsura niyan, 3409.9066 newtons. Ay, sorry, walang newtons. Sine 45. And then lastly, si AY, pababa. So susulat natin siya as minus AY. And if you solve for this, ang makukuha natin dito ay AY is equal to 1574.1681 newtons. So, hindi ko sinulat yung direction ng forces, guys, kasi ang hinihingi lang naman ng problem ay yung magnitudes. And just like that, na-solve na natin si FB, si AX, at si AY using summation of forces and summation of moments and the concept of static equilibrium. So that concludes the end of this video. Maraming salamat at sana marami kayong natutunan. If you like this video, please like the video and subscribe to the channel. And if meron pa kayong ibang topics na gustong ipaturo in engineering science from thermodynamics to strength of materials, feel free to comment them down below.